Hello, everybody. This is the second of our mini lessons for next week. This is going to be covering Module 2.03, the physical characteristics and systems of North America. Now, let's get started by taking a look at this map up here in the upper right-hand corner of our screen. First of all, this is the schedule that we had this week for September 6th through 10th, September 10th when I record this. So you should have completed by Thursday, you should have completed both parts to the quiz, and I'll be grading those this weekend and on Monday. So please make sure you've done that. Also, you still have time to get modules 1.03, 1.04, 1.05 done, that quiz. Okay, so let's get started. Looking at North America, going from up here in the northern parts with the northern parts of Canada and Alaska, going all the way down through Canada into the United States and into Mexico, we can take a look at our regions that are based upon physical characteristics. So if we go down to the southwestern United States and into northern Mexico, what you're going to see is a lot of desert. The Sonoran Desert, the Chihuahuan Desert, huge amounts of desert. These are all desert lands. So then our Great Plains going in through central Mexico down towards the south and up into central Canada, you're going to see your Great Plains. Along the western edge of the Great Plains lies the Rocky Mountains and the Sierra Madre Sierra Mountains, the Sierra Nevadas. The Rocky Mountains, of course, are the longest mountain range and the highest mountain range in North America. So they go from parts of, well, actually all the way here from El Paso, in reality, going all the way up through parts of New Mexico, mostly into Colorado, and then Wyoming, Montana, Idaho, the Dakotas, and on into Canada. All right. So those are your mountainous regions. That's a region based on terrain. Your Great Plains. These are grasslands. The Great Lakes region. This is a lot of woodland, a lot of deciduous forest. Deciduous meaning that they shed their leaves every year. And so this is a lot of deciduous forest here in the Great Lakes region. Going up into Canada, a lot of Canada. All right. See, we got grasslands, woodlands, tundra. Tundra you're going to find up in the northern parts of Canada and into Alaska. And tropical forests, you're going to find them along the southern part of Mexico and the border with Nicaragua. Okay, moving right along. Central to geography is the belief that there is a pattern, regularity, and source to the locations of human and physical phenomenon. Why do we live where we live as we live? A lot of it has to do with spatial patterns. The spatial patterns around us. A spatial pattern is a perceptual structure, a placement or arrangement of objects on the earth. So, for instance, a mountainous region, that's a spatial pattern based on the fact that the Rocky Mountains are there, for instance. All right, how can we describe North America using some of our theme of location? Relative and absolute. So relative location, for instance, Alaska is northwest of Canada and the United States. It's in the northwest region below the Arctic Circle, to the south of the Arctic Circle. Here's the Arctic Circle. And actually, parts of Alaska are above the Arctic Circle. Russia is on the Asian continent to the west. But really, this is the weird part. If you look at the globe, it actually goes around far east. Okay. Greenland is to the east. This is a very icy area. It has a lot of fjords, a lot of glacial features, and a lot of volcanic features as well. Okay. The Great Lakes region is in the northeast, north central part of the United States, right here. Texas is in the southern and southwestern and south central parts of the United States, north of the Mexican border. California would be to the west of Texas. Florida would be to the east of Texas. All right, absolute location. This is where you get your absolute spatial numbers based on latitude and longitude. So, for instance, Texas lies north of the Tropic of Cancer. The 30th parallel divides Texas almost in half. Half of Texas is below it, half of Texas is above it. That's 30 degrees north latitude. Okay. And your longitude goes from 105 to 110. It goes about 107 actually to the west. And on the eastern sides of Texas, you're at about 95 degrees west latitude. Longitude. And let's see. Sometimes I get them mixed up. So if you get them mixed up, I understand. All right, so Canada, the Canadian border is right around the 50-degree north latitude point right here. And here is 45 degrees, so it's around 50, maybe a little higher. And then it goes on way up here to into the Arctic Circle, the 75 degrees, above 75 degrees north. 90 degrees north would be the North Pole. Okay, so if I were to ask where Alaska was, it's 60 degrees north and 150 degrees west to about 160 degrees west. Those are absolute locations. Okay, you can get the absolute locations from your GPS points. Now, in North America, you can find a lot of ecoregions or bioregions, and these are transcending national boundaries and political boundaries, and these are areas of life. And they describe the terrain and the lifestyle of the biomes, okay? The ecoregions. So, for instance, the coastal plains are in the southeastern part of the United States. And the coastal range would be along the west coast of the United States, going all the way up into Alaska. So this is all the Pacific Northwest going up into Alaska from Southern California. The Basin and Range region is to the west of the Rocky Mountains. The Rocky Mountains are here in number 3. They separate that Basin and Range from the Great Plains. The Great Plains then are on the eastern side of the Rocky Mountains. And then you have the interior lowlands. And you have the Canadian Shield, which goes up into Canada. That really is kind of where the border is, the Canadian Shield. Appalachian Highlands are along the Appalachian Mountains, going from somewhere around Alabama all the way through into Maine in the northeast side of the United States. I think that's all of the regions that we had listed here, but you can see that just based on these ecoregions and bioregions, these transcend national boundaries and borders. These things don't stop at the border with Mexico, for instance. They don't stop there. Okay, they'll extend down and they extend into Canada. All right. So environmental processes, the processes of glaciation, weathering, and desertification. You can think about two ways that landforms and bodies of water are affected by physical processes below. So glaciation. Glaciation is when we study the sheets of ice and their impact on the environment. Now, we can study glaciers as they're forming or glaciers as they're falling apart. And a lot of what we've been studying lately has been glaciers as they've been falling apart and falling into the sea. The study of ice and its impact on the environment is glaciation. It's estimated that glaciers store 75% of our Earth's fresh water. So what happens as they're melting? You're seeing a lot of our Earth's fresh water melt with them. Weathering is the process by which the Earth's surface is exposed to physical, chemical, and biological processes that interact to wear away or change the land in some way. Think of the Grand Canyon. This is Canyonlands, I believe, or Great Sand Dunes. But you see how this is weathered, okay? This is weathering. In this case, water, wind, and soil. Desertification. That's the degradation of dry land ecosystems by variations in climate and human activities, and it causes lands that were once fertile to become deserts. When forests are eliminated, desertification can occur. Topsoil can be washed away, and what you end up with is unproductive soil. Ultimately, entire ecosystems are going to die. All right, so stopping and thinking for just a minute, why should we study glaciation and weathering? Studying of glaciation and weathering help us monitor today's changing climate and investigate how environmental processes and characteristics impact human activity. How do we impact the world around us, and how does the world around us impact us? Better climate prediction is also important because it allows us to better manage agriculture, water supplies, fisheries, and resources. So by studying these processes, it helps us understand more about what's happening, what has happened, and what may happen in the future. Forests. 36% of North America is covered with forests. Most of them are deciduous. These are forests that stay green for only part of the year and lose their leaves in the fall. These play a role. They play a role as habitat for animals, as a source for timber, which lumber that we need, which is a renewable resource to an extent. It's a non-renewable resource if you cut it down and don't plant it again. It's a renewable resource if you allow it to grow back and you take care of the forest to make sure that it does grow back. But you cut the forest down and you don't manage the forest, then what's going to happen is you're going to have a process of desertification, and you're going to have the destruction of your ecosystem. But beyond the timber and the source for animals, it plays a part in our recreation, and it also plays a part as a source of our drinking water. Not the trees themselves, but the lakes and the streams that are there. All right. Again, climate does not know political boundaries. Look here. This is a satellite image of local topography. And if you see the topography and the climate, it doesn't matter whether you're here in the United States or down here in Mexico. Climate is climate. Okay? So each region of North America experiences a slightly different climate. Monitoring soil temperatures is one way that geologists study the climate of an area. Soil temperatures indicate the heat transfer processes that occur at the Earth's surface, And that's what we can see is causing atmospheric changes, or atmospheric changes are causing changes to the soil itself. Local topography, the Earth's surface features of the Earth, and sea surface temperatures contribute to differences in climate between various locations. So this is local topography. This would be the grasslands. These would be subtropical or tropical features. This would be Arctic features, or these would be features such as tundra, permafrost in the Arctic, and these would be desert features. Elevation. In the western portion of the United States, the Sierra Nevada mountains experiences a climate only a few miles away on the highest peaks. It experiences a climate that varies from hot desert, similar to the Sahara. We're talking about Death Valley here. It was 145 this year, as its eastern extreme base, to an Arctic alpine climate only a few miles away on the highest peaks of the Sierra Nevadas. The lakes of the Sierra Nevadas are very sensitive to the changing climate due to the fact that they have very extensive bedrock and very little soil. Occasionally, these are granite mountains. Occasionally, due to nothing more than gravity, weakened rock on the steep slope suddenly gives way and the rocks fall down the mountainside. And the Sierra Nevada mountains are extensively hiked. They're explored by people from all over North America and the world. Now, in the Atlantic region of Canada, for instance, it's located on the eastern edge of North America. It has a climate that is influenced by prevailing westerly winds. The prevailing westerlies are winds that are found in the middle latitudes between 30 and 60 degrees of latitude. Their main role is to carry the warm waters and winds from the equator to the western coasts of the continents. But if they don't do it correctly, then you have these northern polar express temperatures that come down, and they can really affect the weather in the wintertime especially. Okay, El Nino is a weather pattern that typically takes place once every 3 to 7 years. It is caused by unusually warm ocean temperatures in the Pacific near the equator, and it affects the weather of many different places. And in the United States, the location of the jet stream shifts, causing the southeastern part of the United States to experience increases in rainfall and storms. Atlantic Canada, for instance, is located on that eastern edge. Okay. The reversal of oceanic currents in the equatorial Pacific, commonly referred to as El Nino, because of the impact of the climate, has far-reaching effects for human health and for safety and farming and increased natural resources, are primarily felt in the winter months because of the warming of the oceans. The repercussions can be felt in other areas for a much longer period of time. By being able to predict when an El Nino cycle is going to be better or worse, scientists hope to be able to lessen the negative impact. So by understanding the cycle, we hope to lessen the negative impact. But we really don't understand what's going on because it's been kind of wacky. Whether or not you believe in climate change, it's been kind of wacky. And we don't know exactly what's going to happen with an El Nino or an El Nino. We can't really predict yet whether it's going to happen or not. In a normal year, the warmest water is in the far western Pacific over here in the forms of thunderstorms. But in an El Nino year, the warmest water moves eastward across the Pacific, and thunderstorms disrupt the jet stream, and they change the weather pattern. So looking at your climate regions, going up here to the northern regions, you're going to have everything from the ice sheets of Greenland to the tundra of Alaska and Canada. You're going to have subarctic continents below the Arctic Circle at 75 degrees below, and below the Arctic Circle there at 75 degrees latitude. Continental humid conditions, subarctic continental conditions here, continental humid conditions here, subarctic tundra up here. This is tundra. Ice sheets here, and highlands. All right, so resources. Canada has a large difference in resources throughout the country. The two most important industries are timber and oil. The provinces and the territories with the largest share of these have significantly higher standards of living than those areas without them. So here in Alaska, Prudhoe Bay, here is natural gas areas. Here you have petroleum. Down here, look at all the petroleum features that the United States is blessed with, especially here around Texas. Texas is a petroleum state, no doubt about it. In Mexico and the United States, the economy in both countries is dependent upon oil, natural gas, and other natural resources, and these are all non-renewable natural resources. 9% of the resources in the United States are renewable. We use only 9% of our resources we use are renewable. We have, and part of the problem is that you have a limited transmission capacity, such as for wind farms and for hydro and thermal. The United States, for example, the biggest barrier to using that renewable energy in the United States is a lack of available and affordable ways to transmit the energy. Of course, the most prevalent source of renewable energy we have is the sun itself. All right, that's a real quick go through of that section. Thank you for watching. Don't forget that you have you had your test that needed to be done on Thursday, but we're still taking it, so please get that done. If you haven't done 1.04 and 1.05, you are behind. Get that done as well. I'm sending this out on Friday evening, so you'll have it this weekend to get ready for Monday morning. All right, bye.